Okay, so now for an introduction, again, we're pleased to have Tom here. He's visiting for several days and had some time to spend together yesterday, and looking forward to the today's lecture and his time with us today and tomorrow as well. Tom Frantzen started his career as an independent architect shortly after graduating cum laude at the Technical University of Eindhoven in the Netherlands in 1995. Since then, his office, Frantzen et al., which I love that title, won several competitions and has completed a number of notable buildings. In 2009, Tom founded, I have to pronounce me with, help me with the pronunciation here, Lemniskade Projects, together with building manager Klaus Asuren, to develop architectural projects from initiative to completion as an architect slash developer. Which is really interesting and pioneering. In the year 2018, Lemniskade was awarded the Golden Pyramid for that year, 2018, which is the biannual Dutch State Prize for Excellence in Commissioning Work in the spatial disciplines. In 2019, Tom was appointed as a member of the Supervisory Board of Trustees at the Creative Industries Fund, and Tom has chaired several advisory boards and lectures regularly in the Netherlands and abroad, including today with us. So with that, welcome, Tom. It's nice to have you, and we're looking forward to your lecture. Thank you.
Well, Pat, Brandon, and Dustin, thanks for having me here. And I had to fly in, so my carbon footprint budget is gone. And so you all have to build with timber to compensate for that in the future, please. And there's 150 slides coming, but it's so they're not full slides. A lot of them are images, so it's going to be 45 minutes. Don't worry. So I'm going to talk today about two buildings that we've designed and developed in the last decade, Patch 22 and Topper, two buildings that are close next to each other. And to do so, I had to start a project development company. Because as an architect in the end of 2008, I became increasingly frustrated that my clients never asked me to do sustainable buildings. They just wanted me to do cheap concrete buildings. And I thought I had to do it the other way. So I thought, okay, then I have to be my own client. And the only way to do so is to start a project development firm. So I teamed up together with Klaus Asuren, who was a former client of mine, a project manager.
Share your screen. Zoom.
Okay. That one now? Okay, good. So I still have an architectural firm. We're a small firm, so we only work for our project development firm, and sometimes we also work for external clients, but that's only if I particularly like the client or like the project. But I don't have to go out and find commissions. Patch 22 was the winner of the sustainability tender in Amsterdam, the north of Amsterdam in 2009. And what is interesting, it was the first time that the city of Amsterdam tendered a lot, but not on a financial basis, but on sustainability criteria. So the most sustainable building would win the plot, would win to develop that plot. And at that time, sustainability was energy efficiency. So the building is full of solar panels, heat exchangers, gray water circuits, all the technological stuff you can think of, it's in there. But actually, we thought that was quite stupid to have a building that is, because I wouldn't be speaking here 14 years later about this building if it would have been about installations, because the installations, they were already old-fashioned in 2015 when the building was completed. For example, the energy score on the Dutch scale is 4.2, which was very low at that time. But nowadays they already make buildings that have a -0.3. So how sustainable is the build is the title of the most sustainable or the most energy efficient building. So we thought we had to go the other way, and we had met Michael Braungart, the writer of Cradle to Cradle, and we were very interested in his theories, and so we decided we have to start building with renewable materials, and the only renewable materials that we really have in the building industry is timber. So for us, timber was, of course, it's a bio-based and it's a renewable material. It's a very light material, so from a building point of perspective, that is, these are advantages. But also for us, it was a marketing advantage, because building with timber in the Netherlands, it hadn't been done for ages anymore. And so we were a small developer. We had just won that tender. We didn't have money for communications or whatever. But by building a timber building, we got a lot of free publicity. All the newspapers, all the professional magazines, they all interviewed us. So we got the buzz going on by choosing for timber. And you would think that you find your inspiration somewhere far, but actually this is a work of art that was around the corner of my home at that time. It's a work of art by Frank Mendersloot. It's a concrete table with 2 timber tables on top, and then there's a beehive in between. And this more or less is our building. You will see later on, because this is what it is. It is a concrete podium, then some timber floors stacked on top of it, and they are a little bit loosely stacked. And in their identity, they sort of they reference the harbor cranes, and that's it. That's the architecture that we did. And I can also tell the other story how it went. Every architectural office has interns, and interns, they always make models. And our intern had just cut up the styrofoam volumes to create this volume study. And she had stacked them loosely because she still had to glue them. And I passed by to get a cup of coffee, and I saw the loosely stacked floors. I thought, okay, stop. That's what we are going to make. That's the building. So that's more or less where the architectural concept ended. And it looked like this. This was our initial rendering for the tendering competition. And on the basis of that, we won this lot. So we actually, so this is yours now. And then we had to start building. And to start building, you also need to sell. And to sell, you need a real estate agent. And you can see that our real estate agent, she had her doubts about selling a timber building. And because a fair question is a timber building a safe investment? Because a lot of people in the Netherlands also see a home as a financial investment, which it is. It's the best we can do. But so we showed her one of the most known Dutch paintings. This is a painting of what is called the Gouden Bocht, which means the golden corner. And it's the most expensive real estate in Amsterdam. And it looks like brick, but actually the whole structure is timber. It is built on timber piles, 16 meters long. And the whole structure is timber, and the brick is just, it's a raincoat around it. So we convinced her, and she was able to go on and sell all the apartments, and so we were able to create this building. And let's go back a little bit. So what is this building? I already explained that having an energy efficient building isn't enough. You also have to build with renewable materials. And then you get into the concept of circular building design. Although the term circular building didn't exist in 2009, it started with Michael Braungart's Cradle to Cradle, then it turned into circular building later. But circular building, that it focuses on resource efficiency. And we would say that a building is only truly sustainable when users can easily adapt it to alternative requirements in the future. And why is that? Because adaptability, slowing the turnover rate of material use, that is real sustainability. Because we have a scarcity of materials. We don't have a scarcity of energy. We have energy coming in from the sun every day, and we are getting more and more smart in how to harvest this energy. But we only have the material that we have. And the day that from outer space there's more material coming in, it's not the day that we're going to need it, because that will be our last. So an open building is designed for maximum lifespan, and very important, an unknown future reuse. So for us as architects, that's that's a funny way of thinking about a building, that you don't know the use of the building, and you don't want to know, because we are always given a brief, and it says the building has to perform like this. But to be truly sustainable, you have to design buildings that sort of can accommodate any usage. So then you end up in the support and infill theories and the open building theories. And this is not new. It's these are all concepts by John Hablack, who passed away this weekend at 95. And Hablack was the founding professor of my university. And actually, I was never taught by him. I was taught by his followers. And they sort of had taken his theories into boring concepts. So we were not at all enthusiastic about their ideas. That only came later. But he was also the head of MIT for a long time in Cambridge. So, and what did he do? So, how did he influence architecture? He introduced the concept of support and infill, and he separated base buildings from the spaces that can be customized by the users. And he also initiated the participation movement, where users are much more involved in the end product and have much more control of the living environment. For that, he developed methods and tools for design and construction of adaptable housing, and he was also critiquing the traditional model of architectural design, as where the architecture is a sole master, and he proposed a much more collaborative and democratic approach for users' rights and abilities. You can imagine that when I studied at university, it was the early 90s. So, and we were full of Ram Koolhaas and OMA and the big concepts. And so, and all this, user involvement, that's didn't ring a bell with us. So it only came later when I started investing my own money that I thought, well, it's my money, I earned this, it's expensive money, so I can only spend it once. So how am I going to do it? And that's when I sort of started to appropriate his concept of Hablack. And this is an interesting book to read. It's also in English, then it's called Supports and Infill. And I don't know if any of you know the diagram of Stuart Brand. I'm not going to show it because it's always shown. Actually, this is the same diagram here on the right. It says you have a site And the site will be there forever. And on that site, you will have a structure that will be there for hundreds of years. And the structure will have a skin that will also be there for decades or centuries. And then inside that skin, you will have a space plan, a floor plan that will be there for a number of years, and then it will be adapted. And inside that space, you will have some services, your cooking devices, and they will have to be replaced after 10 years because they are not efficient anymore or whatever. And then inside that house, you have all the IKEA stuff that will stay there for perhaps a couple of years. And that's actually the Stewart Brand layer diagram you have here. And it was already developed in the 60s. And we are shown this diagram now over and over again when we are at congresses and conferences on circular design. And with this series, a number of architects in the Netherlands, we founded the open building community. And we have 14 founding fathers, all architects that we all chipped in to get this ideas going again. We wrote a manifesto about how we want to design buildings. We have research teams, and one of the research teams is open building with timber. And so I'm also going into how to build with timber today. A lot of case studies. We document all our buildings on the website, so if you're interested, have a look at it. And also important on the bottom, we have developed a classification system, and it's a qualitative qualification system. So it's not quantitative, but it more or less says if we want to speak about a very flexible or a maximum flexible building, this is what you have to achieve. And there are things like that installations don't coincide with the structural, with the structure, that you don't have load-bearing division walls, that you can have a removable facade. So these are all qualitative elements, and we want to stay in the blue zone, so the very flexible or maximum flexible zone as a group. So what is a flexible and adaptable open building? For me, it's a building that has no load-bearing walls. It has no shafts inside the apartments, because shafts will always be in the way. If you have a shaft inside in a floor plan layout of an apartment, you will not see it when the apartment is finished, because it's hidden by the kitchen and the bathroom. But if in the future you take the kitchen and the bathroom away, you will have the shaft standing in the middle, and then the next floor plan will also put the kitchen and the bathroom to that shaft. So you just have, if you want to make a totally open building, you have to get rid of the shaft. And of course, the question is, how do you do that? You also need to have all utilities inside all of the floors. And you have to be able to replace them later on. Also very important, electricity, water, and heat meters. At least in the Netherlands, they are, you have the building code that says, well, it has to be this wide, but you also have the electricity company that has its own private regulations that you have to deal with, and they are even worse than the building code regulations. They would say, for example, that the electricity meter has to be within 3 meters of the front door, and there has to be a door between the living room and the meter. But if you don't want to know the floor plan layout of the future, you don't know where the living room is going to be. So if the meter defines where the living room has to be, then you have to get rid of the meters as well. So there's also how to do it. And very important, I don't think a lot of architects talk about this. You shouldn't have any legal restrictions for alternative future use. Because I can build an adaptable building physically, but I also have to be able to use it legally as an alternative use in the future. And that's even, there's more work to do on the in the legal department than on the, well, building is easy, I would say. So the rule of thumb to design an adaptable building is if you can place the toilets anywhere, then you're fine. And because the toilet has the widest drain, and you don't want to simply want to make a hole in the floor, put the drain through it, and then have pipe running up at the ceiling of your lower neighbor. So you have to solve it somehow. So this is, if you solve this, you're fine. So what did we do in patch 22, starting at the ground floor? This was very innovative in the Netherlands. We have a meter room. So we have all the electricity meters of every apartment in the building in one space, which is very normal for an office building. So that's why we made sure that the building, patch 22, is not only a housing block, but it's also an office building. It complies with both sets of regulations. Then we have the shafts in central core, the structural core of the building. And then we just thought, okay, if we can put the toilet in the outmost corner of the building, and we have enough sloping angle in the floor to get to this central shaft, then we're good. And in the central shaft, we made it so big that we can also have the water meter and the heat meters. They are all in that shaft. And we can divide the floor up into a maximum of 8 apartments per floor. And so we also have 8 front door positions, and we have 2 front door positions extra, because these apartments in the front, you can have very different floor plan layouts if you are able to move the front door. So you need to think of a lot of possibilities in advance. Also the mailboxes sounds quite stupid, but we can do all the adaptations in the future. We can do it without a building permit, because it's already in the first building permit. And so we also have all the mailboxes of all the possible apartments already in the facade, because you cannot change the facade in the future without a building permit. And it's also quite hard to add some extra mailboxes, so it's already there. But also, for example, house numbers. A house number, an apartment is worth more when it has a nice number. So the number 280 would be worth more than the number 278A or B. So we had an agreement with the city that we have a secret list of house numbers in city's administration for all the future apartments that can be activated in the future, so that we have consecutive full house numbers. And as an architect, normally when you design an apartment building, you design type A, B, or C, or let's say maximum 3 alternatives inside a housing block. But we, how many are here? So we are on 16 apartment types that we designed as architects, with all different kinds of scenarios in mind. So we had the double income, no kids. We had the gay couple. We had all the stuff you can think of how they are going to use an apartment in different ways, because they will have a different floor plan. They will want a different floor plan layout, and by doing so, you sort of play the game that you don't want to know how it's used. You only do scenarios, so that you make sure that every scenario is possible in the future. And the funny thing is that none of our floor plans is actually realized. We sold the apartments empty to our buyers, so they got completely empty apartments where they could design their own floor plans with our own interior architects or with their nephew or their uncle, and they could build it with their own contractor, or they could build it themselves. They could, everything inside was their own initiative. And then you see that people are a lot more specific than we as architects can think of in our scenario thinking. But the scenario thinking, you need it for sort of researching the possibilities in the future. So I will go over a few floor plans. This is a floor plan on 2 different levels. You can also connect different units. It's a very nice, it's almost a glass villa style floor plan layout, where the children learn to bike inside, and they also bike on the balcony, with very high floor plan, very high floors. When people can do everything they like, they start installing bathtubs on balconies, and so something that we as architects or one of my former clients would never allow me to do. So, but they just did. Again, an open floor plan, also quite big apartments. We developed this building in the middle of a financial crisis, so we had to sell in 2012, 2013. That was a deep financial crisis. Normal people couldn't get mortgages at that time, and normal apartments were still for sale. And our competitors, so other developers, they started building smaller and smaller to increase the income per square meter. But we thought we had to go the other way. We sold bigger and bigger to get to another type of client, because we wanted a client that wanted a special building and that dared to buy a timber building, a timber apartment. So here we have one of our buyers that had all the timber is still visible, and everything he added into the building is also timber. Here we have one of the smaller apartments. This is 150 square meters of a couple that didn't have much money at that time. So they created a floor plan with the least possible amount of walls, because walls are expensive. So they created this really nice loft space, where you can also see the bare timber, and you can also see that he's very happy with this creation. Then this is our own apartment that I designed for me and my family in 2015. But then, in the end of 2015, my wife was appointed as a professor in Copenhagen, which is in US standards not far away, but for us it's a different country. So we had to move 800 kilometers to another culture, another language, another financial system. And Copenhagen, when you ever visit it, is really expensive. And having a big home in Amsterdam and a big home in Copenhagen we couldn't do it. So we had to sell, which of course, you know, this is my baby. So I didn't sell all of it. I kept the kitchen. So this was sold, and it was completely redone on top of our utilities that were already installed. So you can see that it's possible to create a totally different floor plan on top of it. And this was our kitchen, and we dug some holes in our top floor, and the smallest employee, my contractor, went into the floor because it's a hollow floor, and he cut up some stuff, connected some things. We added the new front. We opened up the front door position, added the new front door. We connected to the central core shaft. And then we applied for the secret house number, so we have 280, and at first we had 282. And then we created this apartment. and it's a 61 square meter apartment, so that's let's say this is perfect for a couple with a Murphy bed coming out of the wall. Because when my family was living in Copenhagen, I also used this as my office. So I could simply get rid of my bed. And here we had a storage space on top of the bathroom, and we stored our kids in there. A floor plan that you wouldn't come up with a floor plan like this as an architect, not often at least. But it actually is quite a cool floor plan. But when you see this is totally not my style. I hate the style. But I really like it that it's inside the building, because the owner of this apartment, it's her style. She went to Morocco to find these antique doors. She went to Spain to find the right tiles for her individual expression. And I think that is very important and very cool. So let's go a little bit into detail. How was Patch 22 conceived and constructed? As I already said, it is housing, but it's also an office building. But an office building has a higher floor load than a housing block. So it's 4 kilonewtons per square meter instead of 2 kilonewtons. It has a higher floor, so it's totally oversized. Because in an office building, perhaps you need some pipes, some ventilation pipes, and everything day one. So you need the oversight. And our idea was initially to create it with a prefab timber flooring system called Cato, but not to use it like this. This is the official way. We thought of just using the same product upside down, and then fill these, because you always need a ceiling, but you need to be able to get rid of the floor to be able to get to all your utilities. And then you come to the question of how to make timber fire safe. And we are very lucky that in the Netherlands we have a building code that doesn't say how to achieve a performance, but it just tells you this is the performance. So for our building, our structure needed to be 120 minutes fire safe. And inside the tree, there's always another tree. So if the small tree is your structural tree, and the timber around it is only for fire safety, you can let this timber char away. And you can very easily calculate the charring time. So the charring goes by 0.8 millimeters per minute. So 120 minutes times 4.8. Then we have some reduction factors in the Netherlands, because our building code says when there is a fire, there will not be a storm. If there is a storm, there won't be a fire. So in the end, we had to add 80 millimeters of extra timber on top of our structural timber. But that's really easy to do. You just increase the sizes, and as Michael Braungart already explained, when it's renewable, it's okay to use a lot of material. But then we got to this point that our structure had a lot of surface, so we had to add a lot of extra timber on that surface. And because this timber is high-tech timber, the timber is quite expensive. So actually, it was too expensive, this idea. So then you have to come up with another idea. So we found a product that worked as a sort of a prefab timber slab on which there's prefab concrete slab on top of it. And then we would have a raised floor on top of that structure. That was already better because the surface of our structure was less. but was too expensive as well. You know, and I'm a project developer, so I also have to make profit. So then our contractor came up with an alternative flooring system, and he wanted us to use the slimline flooring system, which is a totally it's a floor plan system, you know, that has been tested and everything. So they didn't dare to experiment too much with the floors in the building, because the building also had to be insured, and the insurance companies, they are risk avoiding, so that was quite a problem. So we used this this product, and in this floor we have all the utilities, so you can take off the top floor, and it turned out that was still too expensive. But anyway, that's, you know, we were already too far in the process of building, so this is what it is. Just was too expensive, but it, you know, technically it works perfectly. You can take off the top floor, and then you can install all your utilities, and to suit to your floor plan layout. And this is what it looks. This is our apartment, what it looked like before we sold off 3/4 of it. So all the pipes and drains and everything are already in the floor. And the building itself has been built with a lot of timber components. So it's a timber post and beam structure, again, to decrease the surface of our structure. If you have load-bearing walls of CLT, you have so much surface that you have to add so much charring timber that it becomes enormously expensive. So it's kind of paradoxical. Normally, if you build a post and beam structure, it's more expensive. For example, in concrete, the post and beam structure is more expensive because you have more connections and you have more casting. And that's why in concrete you have load-bearing division walls. But so all the components are built of timber. Then the components are packed together into bigger components, and they are installed as prefab components on the building site. And here you can see that when you have a timber construction, you have a lot of steel connectors in between, and you have to protect these steel connectors to fire. And the funny thing is that the timber you put around it, it protects the connection. This is the same detail, but seen on the other side. And here it's in reality, but it's, you know, rotated 90 degrees. It's on the building side. And this is also an interesting detail. Normally, you would have a beam, and then you would make the beam like this to have oars lying on top of it. But imagine a fire, and then the red part chars away, then the floor would fall downwards. And so that cannot happen. So we added, and you will see it here. This here. So structurally, the beams hang on top of the beams, and not on not over here, where it normally would be in a concrete structure. So this is what it looks like when the building is totally empty, when we sold it to our clients. And to build it, we had to hire a prefab concrete company, because nobody in the Netherlands had experience with building timber buildings like this. But it really resembles prefab concrete building. The only thing was that normally when these concrete builders, they have these steel rods, you know, with which they push the elements, and that's okay because the concrete, they will repair it and paint it and everything. But you cannot do that with timber. So we bought a lot of brooms for them, and so we had them use brooms to position all these elements. And well, they found out that it was actually as easy as building with prefab concrete. But you also see that they make mistakes, because in our detail, this was felt a rubber or soundproofing issues, and they had cement in between, because that's what they normally do. And this was on a day that we weren't on the building site. So then shit happens and you get problems. This is another important detail: how to connect a beam to the core. And the beauty of building with timber is that you can you can mill away a lot of the material, so you can make very special detailing, and you can use the timber again to protect the steel connectors in case of fire. And I already explained that building is a little bit like this, and therefore it was really good that we built with timber, because all the endings of all the beams, they can all be different because they are just milled. So you have all these, you can do a lot more special detailing in timber than you can do in concrete, because in concrete you have to build the casts first, and then they all have to be the same, because if you have to build 25 different casts, it's incredibly expensive. But with timber you can just mill it. This is a detail of the facade. With us, it's we are lucky. It's allowed to use timber on the facades of high rises. Well, of course, they are treated for fire safety. But in this way, we could detail the building that it looks like different boxes. And very important is that we use the windowsill as one of our main detailing ideas. We have windowsills going over every level and dividing every level, and dividing, you will see that in the next. Because we have these different boxes, and once you start detailing boxes that slide over each other, as an architect, you will always have the problem that the floor and the ceiling sort of intertwine. And by using this windowsill and making really clean cuts, we were able to suggest this shifting of boxes on top of each other. Then the Netherlands have a very mild climate, so we have a lot of rain. It's moist and it's never cold, so we have a perfect climate for microorganisms. And so here we have the nice rendering on the left, where you can see the fresh timber color. And as an architect, you would love to make the photo of a completed building look like this. It's still fresh, but it will never happen, because the timber, it will be affected by UV, and it will be affected by rain and microorganisms. So in our climate, you will get these black sort of shadow lines underneath, and it will just look ugly. So we decided to pre-grade the building completely, because when timber is affected by UV, and it will end up gray. So we just decided to pre-grade it in the beginning, so that it looks totally, it all has the same color. But also all the structural detailing is at the same time waterproof detailing. So all our connections are at the same time sort of caps going over the top of the timber beams. So this is what the building nowadays looks like. And we were happy that when we were building this building, we could buy the plot next door. And on that site was an old industrial building. And that building didn't look nice, but it had some interesting concrete walls inside it. It was the storage for the transatlantic telephone cable from Europe to the United States. So it actually is a huge cable wall with a lot of concrete in it. And for example, 140 piles to the first sand layer. Amsterdam is a swamp, so we have to build our piles. So there was already a lot of concrete inside the ground. And as a developer, when you have to start to touch the ground in a formal industrial area, that is a huge risk because the soil can be polluted. So we decided to keep it. It's also from circularity point of view is better. Just keep all the material that's there. And we added a building to it. So that's why the building is called Topo. And for this Topo building, we researched all the available timber construction methods at that time. So we had a look at rock commons in Canada. We had a concept of sort of super CLT that was stacking CLT slabs on top of each other on site. We looked at the WU+D building in Vienna, where it's interesting that they have a combination of timber columns and concrete beams that solves the problem of having the different directions in the timber. You can never have a column on top of a beam directly because it will simply punch through the veins. Presses. We converted that to an idea where we have a concrete beam and then a CLT floor plate and then in pseudo cast concrete on top of it to make it a whole floor. We got back to our original system of patch 92. How do we build this? And we had a look at a prefab concrete system called the CD20 system, which is a concrete prefab system that is based on timber connections. These are concrete slabs that have steel connectors in the corners, and so the connection with the columns is over steel, and that way you can really easily take it apart. But conceptually, this is a timber system. This is how timber structures are. And we just made calculations. How expensive is it? What is our budget? And what can we really invest into timber? So of course, this is what we wanted to achieve, a completely timber structure. And we would have been able, if our land lease contract with the city wouldn't have been very, 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 very expensive. So we ended up with a combination of timber columns and the prefab concrete floors. Now I'll show you quickly how to build it. We were able to build this building in 22 days, wind and watertight, inside the city. So this is an inner city site. We had the building prefabricated in Germany. It was put on a boat. It was unloaded in the Amsterdam docks. Then we were able to have small vans driving in circles. That was because they were small, they were allowed as inner city traffic. So we could have a very well-planned building cycle. And we had four days per floor, but we actually only built 3.5. So instead of this building phase is always, it's very frustrating and very tense and very stressful. But because of our building system, this was a totally relaxed site. And again, the floor plan looks like looks like an office floor. And we had different possibilities of connecting units, not as much as a patch 92, but it was a different one. Again, we designed a lot of floor plan scenarios. And again, none of these floor plans were used. Here it works this way, that you have you have the cabinets, the warm meter cabinet and the cold meter cabinet, you have them inside the corridor, and you have a drywall division wall. But this is what it looks like in reality. We also have the ventilation box, so all the utilities that need to be there because of the building code, they are all in the corridor and never inside the apartment. So the apartments are totally empty. And you only have the connections. So when people board their apartments, they would step in, they would step 23 centimeters down, and it would be a package with which they could install the floor. Because our buyers had to build the red part themselves. And inside this red part, you can have all these utilities. And we as architects, we designed the manual how to build your infill. And we decided not to think of an infill industry, because you don't know who's going to build the infill in the future. And if you are going to use a high-tech tile or something that you can remove, it will not be on sale in 30 years. So we really designed a raised floor system that is stupid, that anybody can build with just a drilling machine and a sawing machine. And so that every contractor in the future can just do it, and all these materials are available. So this is what it looked like when our buyers got their keys. Then they would start building their floor, adding the insulation and all the utilities inside, adding plywood on top, then adding screed slabs on top, prefabricated, with floor heating, with radiant heating inside. Again, you get different floor plans, totally different floor. Again, bathtubs on balcony, of course. You get the bathrooms close to the windows. Well, perhaps Amsterdam people are a little bit expressionistic. But again, you know, imagine living in Atlanta on the 37th floor. Wouldn't you like to have a shower with a view? Yeah. Oh yeah. So love it. But here they do it. Different styles. So this is our own floor plan. When after 4 years we came back from Denmark, so we bought another apartment. This block, so this is our new interior, and you end up with very funny floor plans. These are adaptable floor plans. So there's every apartment is different, and they will be changed over and over again, and they already have been changed. I'm sort of coming to an end. The expression of open building, the urban expression, of course, is very important. This is more or less the dream of open building, that you have sort of a neutral structure in which you can build your own villa. And this is really fun as long as it are villas. But imagine this structure with all these nice villas and ranches in it. That would look crazy. It's architects went free. But then you have Ready Player One, Steven Spielberg. You see what happens if you do the same for lower income housing. Then suddenly it's not so attractive anymore. So we have to give buildings expression. And I think individual identities, they shape the interiors. Collective identities, they shape the buildings. And individual buildings, they shape the urban identity. So with patch 22, it's this. You can simply tell your friends, I'm living in the house, in the apartment. You'll find it. It's or with the diagonals. Come over, you'll find it. It has this expression. Top-up also has its own expression of these boxes stacked on top of each other. Like you could explain, it's like a palm tree. Or there's a little side step. Detailing is very important. By having these tapered floors, the timber facade is never wet because the rain runs over the windowsill, falls down, and because the facade just tilts away, the water will never reach the facade. And in that way, timber is still really beautiful after a couple of years. The corners, very important in this type of building. And I want to give a little tribute to my detailing professor, Jan Westa. Whenever there was something he couldn't solve, he used a mirror. And with timber, you have directions, of course, and you can see that you have directions from two sides. And you could only solve it by having it on a 45-degree angle. But then your timber planks become too short to screw them to something. So that's not possible. So that's why we added mirrors in the corner. But people can say, I either live in that building like this, or you'll find the building with just look at the ceilings and the mirrors in this corner. Very important, and I'm almost finished. The balconies, they serve as intermediate spaces between the totally individualized interiors and the urban identity of the building as a whole. And inside these balconies, you can do whatever you want. You can have the bathtubs, it's sort of an in-between space. This is only stuff. So this is not architecture, this is stuff that's put into the space. This is the same space, but then on top of it, it's also totally finished. So people are also not able to change the finishings of these spaces because they are owned by the community of owners of the building. They can only add their own identity in it with stuff. Then to come to an end, a lot of you are starting architects, so you will be starting with smaller buildings. But I think it's very important to think oversized, think bigger, even if the projects are small. And to give you a small example, one of the last projects that we did was artist residences for the Frantzen Center in Belgium for the Flemish community. Frans Mazereel was a woodcutter, so he's famous for his woodcuts. And of course, it's easy to propose a timber building. And his old atelier, his old studio was converted into a center for graphic arts. And they have artist residences all year long. And somehow this site became a collection of circular buildings, circular as a shape. And here we use all of our ideas, the open building ideas that you can modify the floor plans completely around the central core of COT that has all the utilities and all the shafts, and a sort of oversized balconies around it that create the image of the building. Thank you.